Bismillahirrahmanirrahim. Hello everyone. This is our complete STAADPRO tutorial course. In this course, I want to model this structure. So this structure is about 30 meters length and 15 meters weight, and it has 6 stories. So we usually have one bracing system here, and one bracing system here, and one here. So totally 3 areas bracing. We have a primary section, primary beams, and also primary beam and secondary beam. Now you can see here for the primary design we selected the beam 500 IP 500 and for the secondary IP 300. For the column 460 we will add this superimposed date load and also this live load, and the seismic parameters is 1.2G and 0.82G. So the structure system parameter is R7 CD 5 point, and you can see for Dawao bracing system you will see this in AAC 716. So finally, after designing, we will do detailing using this software, the STAADPRO software. So we go quickly to the modeling, and we're using called STAADPRO complete tutorial, and we have 2-3 kind of choice to do. We can bring the plan of the building, and also we can physically model, and we also use analytical. So most of you may be familiar using analytical, so we're using analytical model, and it's called yes. So we can define grid also is possible, but I'm using structure wizard, which is quite fast. Using frame model, and I'm using this function, and the length is 30 meters, which is divided by 5 base, and totally 6 meters. So the height is 19.2 meters, which is each story is 2.3. So number of stories, this is 15 meters, and finally we have 3 base, which is 5 meters. So this is the structure model. Now here is the model. We can go to, we want to define first the bracing area. So I go to the view, and I want to select the top view, and I want to create a bracing system here and here and here. So first let me select this one, and I can go back to the 3D, and I selected these frames, and I go to new view. It's called OK. So I selected these beams, and in the geometry, and I'm going to call insert node in this beam. So this length is 5 meters, so the middle is 2.5, which we use inverted bracing, inverted V bracing. So now I can select the beam and adding here to here. Now I can select beam cursor and selecting these 2 beams. Now I use this command, it's called duplicate. Let me use 5 in the top stories, which is Y, and each story is 3.2 meter. And you can see the entire process modeled in the one direction. So what's next? And I'm going back to view. You can go to structure only, and you can see the entire structure is again come back. We go to here, and this time I want to select this one. Selecting this one, I'm going back to the 3D, and you can see here. So what I want to do is I want to geometry and repeat this in the Z direction. So this is Z direction, and it is 3 meters. So 1 times. And I'm going to OK. Sorry, it is Z is this side, so that should be X. So that should be X. Let me go to the view, top view, and we can see where exactly that is located. Oh, it's we brought this here, so I'm gonna go undo this one, and you can see this undo, and I'm gonna select again. So now we are called Z X. I'm gonna repeat in the geometry and here, and I'm gonna call X, and it's going to be 3. I'm gonna OK. So now location is correct. So one more thing, I'm gonna go to again, so 3D dimension, and in the 3D I can select just these these 2 brasses, and after that I'm using the same geometry here and the same X, and going to be 3 meters. 3 meters. But if I use this one, so they will be creating a extra, they will break together. So let me first do it how it looks like. So if I select this one, now it's break, it is not correct, so I want to use like this one. So in an article it will break, but in the practical it's one single element. So now I want to select this again, these two brasses in the last part, and I want to repeat this to the y direction. So this is y, and using 5 times, and this is 3.2 meter. So now I'm going to go, and we can see the entire model is completed. So I can go back to the view, top view, and I want to select these parts. So this part, and I'm going to go to 3D, and let's see the entire frame is added, selected, and I'm going to here called new view, and I call OK, and now we have this one. So here just I want to add another bracing, and I can go to the geometry, and it's called add beam. So I'm going to select this point to going to be here, and using this point to here. Now the good thing is we draw one, and here we can duplicate again using this one 5 times, and this is 3.2, and in the y direction. So I'm going to go OK, and we can see. So if I go back to the model view, and it's called structure only, and structure only, and you can see here the entire model is completed. So the bracing and other frame. So now we have just the secondary secondary beam in one of the plan, and I want to select this one, select this one, and select this one, select this one, and also I can select this one, this one, this one. So now I'm gonna go to again to geometry, and I'm using duplicate, so it's X. So what we're gonna do is I want to add two other extra bracing. So it means this is 2 meters, 2 meters, 2 meters. So I'm gonna back to the STAADPRO, and I will say let's give 2, and it should be 2 meters. So I mean 2 meters, 2 meters, and it'll be okay. Now you can see we created other 4 bracing. So now in here I selected this one and selecting this one, not this one because we don't have other extra secondary beam here. So I'm gonna go to here, and I can select this and this one and this one and this one. Now using this one, so how many I want to just 2 and 2 meters in the X direction. So we finished, and the same we model like our building. Now you can go to the 3D view, and this is view, and I'm going to 3D, and the entire secondary beam is also added to that structure. Now we should define the properties. We should define the properties, and we can define the properties which is already given. So the first is called section database. We can go to the section database, and in the section database I want to use European code, European profile. This is American, and you can come to here and it's called European. So I'm using IPE section. IP section, so we need IP 300, IP 300. This is IP 300, and we have IP 500, and this is IP 500, and IP 460 for that column. I think 460 is not exist. We can use this one. 450. Now we define these three. So let's define the column first. So this is the column, and I'm going to the geometry, and here in the beam you can come to so in a selection you can come to the beam. This is called parallel to Y, which is the entire columns, and I'm going to assign this to selected beam. So if you go to the rendering, and you can see, so this is the column which we define to the structure. And next is I'm going to select the X. This is also the primary beams. I want to use this one, and again primary beams, and it's called a sign. Now we can go to the here parallel to Z. We can select the parallel to Z, but so this is the secondary beam. So I'm going to this one and selecting this one, and I'm going to top view. So I want to select the primary beams. So this is the primary beam. Press the control, this one, and this one, this one, this one, this one, this one, this one. So okay, it's okay. Just so this is we can merge this again after we finished assigning the elements. Now we can go to the 3D and see what we selected. We selected the brassing as well, so I can go to the one of the elevation, this one, and I'm going to control, and we don't need this shift. I think I lost them, and I can go back to again. Let me assign them properly and pause the video. Now I selected the entire primary beam, so I'm going to 3D. Now the secondary, the brassing also selected. I'm going to one of the elevation, so I want to deselect them. So I'm going to deselect, and if I go to 3D again, oh, so there was one problem which we selected the column as well. So I'm going to go into this view, front view, and I'm going to deselect. Okay, now we selected the other primary beams, so I'm gonna assign it, but some other brushes also, because it's inside and it's difficult to deselect them, so I will use other method to deselect or change their elements. So I'm gonna adding this on assign, and now we assign them, and I'm gonna go rendering, and you can see we have primary beam and also some brushes. So the next I'm gonna fix this one. First, let me go to the top view, and in the top view I want to select this area, and you can see exactly you have this one. So I'm going to go call new view, and we go to the 3D, and here it's very easy to change the bracing. I'm going to one of the view. Now I'm going to go to select this bracing, and I'm going to come here and selecting the bracing and all the brass. And this is one direction. If I go to 3D, and now I want this direction, so I be here front. So here is, and here is, here, and here. So now I can go to assign. So now we selected. If I go to the 3D, and you can see this brassing area. So this is the brassing area we created in the middle of the structure, like a core area, which is one for the stairs and one for the lift. Okay, we can go to the back view, and now we can go to in the view and call the structure only, and the entire structure is here. If I want to using 3D, and you can see that 3D model is almost done. So we have something extra here. I'm not sure why they are here. I can delete them. So I want to delete these some elements. Here is some. Let me finish. Now we can see it is we deleted that extra during the copy, and we had one more, so that was wrong. And now we are about to model the secondary beam. So I'm going to back to the structure only, and here I'm going to top view, and I want to select the secondary beam. We go to the back to the properties, and view, and I can come here, selecting this secondary beam, this here. So this area is the brass, and I'm gonna select uh, select these brasses and these brasses and these brasses, the secondary beams. So we have selected just two waves left here, and now I want to assign this section to the structure. So we define, and I'm going to 3D rendering, and you can see this is added. So this is added, and it's correct, so no problem. Now we want to go to the material. We want to go to material is using still 50 KSI, and I'm gonna call it add to view, and we can see we change the material to A30, A50. Now the last one is when adding support, or we can create a support, so the bottom is fixed. And one thing I should say that uh, we should create some release, and I'm gonna selecting that the entire secondary beam and also brassing is called end release, so there's no movement in edge. And I'm going to call select this one, and I can go to the geometry. In the geometry, I want to add end release. In the specification, you can come to the beam here, and it's called release. So the first one release is using the moment, which is in the start, add, and we can go to again, assign to selected beam, and call assign. So we assign in, and now we can go to again again release, and going to the end, the same moment should be 0. Now we can go to the end and assign to the selected beam. Now this is closed, and we can go to the top view, and this is top view, and you can see all secondary beam has a moment release. And also if I go to the one of the electro, you can see this also has the end moment. And one more thing, I should go back here and select uh, this beam. We can consider it as two separate elements, so no problem. Now we go to the support, and we can go to the view, front view, and now we're creating a support, fixed support, adding here, and now we can add this to the bottom of the structure. So called use to cursor. I'm going to select these things, this bottom, and it's called assign. So now we created the boundary condition as well, so I'm loading. So we have totally 3 kind of load. One is earthquake load, and one is date load and live load. So the wind load is neglected in this study, so this is analysis. So I'm going to first define some reference load. I can come here, and it's called reference load. I want to say date load because we want to define the mass source for the seismic analysis, or using equal lateral method, equal force method. So they will calculate the weight of the structure and then transfer to this mass and calculating the shear force. We call it DL, calling add, and it's called live load, double L, and we have these two mass sources. So I'm going to add. So the first is the self weight of the structure, and the second is using floor load. So the total floor load is 1.2 K minus 1.2 K, using the height of the structure to height of the structure 1.9 in the y directions. Now you can see here, this is the load, and the self load should add to the view. And in the live load, we will add flow load, which is minus 2.5, using the y direction, and 19.2 add. So now you can see that. So the second part is I want to define a seismic load called seismic load, and the seismic load I use ASC. You can use IPC. This is the same. I use the 16. I can get if you are located in the United States, so then you can give the zip code, so the program will determine this parameter. If you are not, so then you can change this one to, so this automatically. So I'm gonna call so there is no exist these things, and I want to give my data 1.2, and this is 8.2. So I consider the long time period is 8 seconds, and I'm putting factor, so this is 7 in the back direction, and this class, the soil class is class D, which is steep soil, and the other parameter will be automatically calculated. So I'm gonna call OK. So I define this seismic load, So now the seismic load I need to give the mass, the previous one. So I'm gonna call here, and it's called reference load. So we call add, which is 100% of the date load, and now this one is called 0.25%. So I added these two. When I give this one, and the program will determine the base shear. So now in the load cases, I want to add again that live load, so date load, and we call DL, add, and I call live load, LL, or flow load. So now I can give this date load on add, and I using -1, and the second called floor load, minus 1.2, yes, minus 2 and 19.2, add it. And the second one is the live load using floor load, and minus 2 minus 2.5, and to the height of the structure. And so this is okay, this double, and I'm going to delete one. So we're going to delete it. So one is deleted, and now we're going to assign this self load to the structure. Assign to view, and here is in the load case, I should define one seismic load, or the seismic load mass and parameters given. So now I should give the direction as well. So here is called seismic load. Sorry, not here. And in the load case, I'm going to call add. Here is called seismic edge. So I'm called EX horizontal, and I can give EV, which is fine. We also have uh, some other things like giving it a minus and positive, so that's okay for you, for me. So one direction is this symmetric, so it's equal. So in case some structure with eccentricity or with complex shapes, we have to give minus positive as well. I'm gonna go here. Now here is giving to add into each direction, giving that factor. So the first factor is, and I come to the seismic load, and it's called factor. The first one is X, and this one is called add using Z direction. Seismic, and it's using Z direction in a positive. In case if you want to consider the accidental torsion here in the structure, or natural torsion, you can consider, but in this study I neglected. So now the load is defined and completely. So now what we're going to do is we want to run the analysis and see if there is an error to fix. So after the analysis completed, we want to design. So I'm going to call the analysis, and I want to command, and I consider to all things for me, and I'm going to call the run the analysis. It asks me to save. So when we run, and now we have one error, and let's fix this error. And we can go to the output and see what's this error for. Including the error, we have some note. This is called a note, neither mass or nor gravity difference load present. So it means mass model forms will be used in the seismic. So we actually giving this using the reference load to the seismic to calculate the seismic force. So it's okay when ignore this, and I'm going to get error, and here. And now here is the error. So called error means IVC load case must be defined before any other case. So this is the problem, and I'm going to show you how to deal with this. So you can go back to the loading, and here in the load case, before you define in the EXEZ, you shouldn't define any load previously, because the otherwise this load will comes with this load instead of the considering the earthquake load, so they will again using the dead load. So you should remove this. I'm going to delete this one, these two load, and now I want to add load cases, which is dead load and live load. So I'm going to call dead load again. Now we're adding the live load as well. I'm going to live load and L. So we can go to apply again, add, and self load, considering floor load minus 1.2, and to height of the structure 9.2 meters, 19.2 meters close, and the live load is also should be adding this here as a floor load, and it's minus 2.5, minus 2.5, and to the height of the structure 19.2. I'm going to call that. So just the self weight should add to the structure again. Going to assign to view and assign. So now the error will be solved. So one more thing is I'm going to go add one automatic load combination. So you can use different code is available, and I'm going to use AISC19 because it's a steel structure. So I'm using this combination. It's called generate. So we have this difference combination, and I'm going to add it. So this is the combination. You can see 1.21, and here is -1, which is the earthquake load. So now I can go to design part. In the design part, I will define steel using this code AISC3016, and I want to select some parameters. So the entire parameter should be selected, okay, and I'm going to define some command. So what I want to do is I want to just check code, and also I want to select optimization, and that's all. So I don't need to add another thing else, and I'm going to check to entire structure. And now so we finished. So we can go to run the analysis and design again. So save it, and it's called your module contain instruction of members, selection optimization options. These are not followed by an that will not be consumed with the new member. So because we use optimization, in case if our defined doesn't work, so the program will give us a proper member. So now we can go to see here, and there is no error. So this is the member design. Yeah, we have 0 error till now. When you consider the optimization design, so it will use different members to check it. So we can go wait a while, so it takes some time to finish. Okay, then the design is completed, and we can go to see the output. And now it's called final result, and this is the loading the analysis part. And let me go to see total applied load, and we can come to, down. It is called internal joint force, and we also have the equivalent lateral force in this is the equivalent lateral force which is created in the y direction, in the z direction, and the torsional moments also. So we can go to the member. So the first member is passed, so this is the ratio, and this is the moment, and so we can see checking the error. So warning, so the warning is nothing. So means this is one problem in during the creating the brassing. So we have divided the beam to the 2 parts, so it means there is some small statement, and you can see the statement is exactly the same with that one. Now mostly we can check the entire members, and this member is passed. Yeah, passed. We don't have any failing members. So now we finished the design, and also we can go to the post-processing to see some results. And now the result enable, so shear force, bending, torsion, light, okay. And now let's see, this is the first combo. I'm not using combo, I'm going to use EX. So UX is in this direction. You can see the displacement. This is the displacement. This is the displacement, and you can see the horizontal displacement in UX summary, and maximum minimum in UX, and it's 90.5 millimeters, and in the Z is quite large. In the Z is quite large, you can see here, and result on 75. So but we have a brassing system, so that will cost. So one more thing I want to show you, that using this one, and it's called the beam result. And now I want to define the EX, and this is the EX, and you can see the EX moment, force, everything. So I want to show in this graph, and you can come to the can go back to the analytical model and in the loading, and we can go to load cases, and I want to see the EX. So here is the EX effects, and we can go to the labeling and view, label setting, and you can see the V shear, how much force is added. So here is the 8 joint equivalent lateral forces in the Z direction as well. So let's go to the Z direction and this direction. So now the design is finished, and we can go to the detailing. We're using still auto draft, and you can use this one, still auto draft, and it will create a view for us. Now this is the model, and what we're gonna do is we want to create some drawing list. You can select here. So I wanna use first the plan, and I wanna consider the first floor, and I'm gonna call this called add to drawing. So I'm gonna call this one called draw, and you can see the drawing is like this. So this is my first floor plan, like this you can see, and here is the program automatically determine the that's a single total one beam. So we have one column, so it's a small beam here. So this is the first floor, and we can go back again to the view list, and this time I want to select, you can see this is number E, which is equal, DE is equal to the section. So I'm going to call section across X, and I'm going to call across Z in this direction. You can reduce the scale and using wedge length, so totally 15 meters. So we have 15 meters. I'm going to call let's go to 10 meters and call this one called add, and we can go to drawing. So there you will see the bracing. So bracing is not existing here, and you can see the bracing point and the secondary beams as well. So we go back again, and this time going to select section in Z using 5 meters, and going to draw. So now you can see the bracing system. So like this you can create the entire, you can see here the section names and the total weight of the structure, steels. So then you can export this to some CAD file, and also you can save it here. You can save it as DXF file, and later you can open in AutoCAD and edit it. And also you can draw some extra member in case if you need. You can draw so like this you can finish the entire section. And also the STAADPRO, here is the connection design. We can consider the connection design, but I don't think it's necessary for this tutorial. In the next tutorial we will consider the connection here, and also using a RAM connection software. And also we can transfer this data to the IDEA Statica and design the connection there. So this is the end of the tutorial. If you have any question, please put in the comment, and if you like it this tutorial, you can subscribe my channel and keep tuned for the tutorial. See you next time.